Morning, guys. Today we're going to review the set of exercises that I gave you yesterday. These are for lesson 7-1, page 377, numbers 19 to 22. There were only 4 questions, so this shouldn't take very long. So let's look at number 19. In this set of exercises, they gave you a system of equations and they asked you to determine if this system had one solution, no solutions, or infinitely many solutions. Now, in a previous lesson, we talked about how to determine if a system was going to have one, none, or infinitely many solutions. And we said that it all has to do with what the slope of the line is and what the y-intercept is. So the directions say without graphing determine this, which is good because we don't need to graph to determine how many solutions a system is going to have. So let's look at question number 19. Now, the first thing we need to do is look at the equations themselves. We need to be able to pull out the slope and the y-intercept of these equations. So the easiest way to pull out the slope and y-intercept is if they are in slope-intercept form. So let's look at these equations. We can see that they are already in slope-intercept form, y equals mx plus b. So it's very easy for us to pull out the slope and the y-intercept. So let's start with y equals 2x. Here we can see the slope is 2, so m equals 2. And we don't see plus or minus anything, so we know that the y-intercept is 0. Let's take the equation y equals 2x minus 5. We can see the slope is 2, and we can see the y-intercept is negative 5. Now the second step to this, and I gave you steps yesterday, step 1 and step 2, is to compare the slopes and y-intercepts of each equation. So let's do that. We can see that the slopes of each equation are the same, and the y-intercepts are different. And we said when the slopes are the same and the y-intercepts are different, that means the graphs of these lines are parallel. And parallel lines never intersect, and the intersection is where the solution is. So if they never intersect, that means that this system has no solution. Let's look at number 20. Here's our system of equations, but these equations are not written in slope-intercept form. They're both in standard form. So before we can pull out the slopes and the y-intercepts, we have to rewrite these equations in slope-intercept form. So let's start with the first one. We have x plus y equals 4. We subtract x from both sides, and we get y equals negative x plus 4. So it is now in slope-intercept form. The slope here is negative 1. So there's negative 1, and our y-intercept is 4. Let's take the second equation and rewrite it. So we have to move the 2x to the other side, so we're going to subtract 2x from both sides, and we get 2y equals negative 2x plus 8. One more step, we have to get rid of this 2, so we're going to divide both sides by 2. So negative 2 divided by 2 is negative 1, and 8 divided by 2 is 4. This equation is now in slope-intercept form, and we can pull out the slope and y-intercept. Here we can see the slope is negative 1, and the y-intercept is 4. So now that we have the slopes and the y-intercepts of both of these equations, compare them. We can see that the slopes are both negative 1, and we can see that the slope or the y-intercepts are both 4. Well, if the slopes are the same and the y-intercepts are the same, we can also plainly see that the equations are the same. That means that this is the same line. And when they are the same line, we have infinitely many solutions. All right, let's look at question 21. Same rules apply. We're going to look at the equations and make sure that they are in slope-intercept form, and we can see here that they are. So we have to pull out the slopes, and we have to pull out the y-intercepts. So we can see that the slope of the first equation is negative 3, and the y-intercept is 1. We can see that the slope of the second equation is a positive 3, and the y-intercept is a 7. So now let's compare the slopes. We can see that the slopes are different, and when the slopes are different, that means that we have one solution. It's that simple. And the last question, we have 3x minus 5y equals 0. So we have to get that into slope-intercept form. So we will, here's the whole system. And we also have y equals 3/5 x. So let's take this first equation, 3x minus 5y equals 0, and we have to get it in slope-intercept form. So we're going to subtract 3x from both sides. That leaves us with negative 5y equals negative 3x. We don't write plus or minus 0, so that's why there's no 0 there now. And now we have to divide both sides by -5. So -3 divided by -5 is a positive 3/5 x. So now let's pull out the slope and y-intercept from each equation. We can see the slope here is 3/5, and since there's no plus or minus anything number, that means the y-intercept is 0. And here's our second equation right here. So we have y equals 3/5 x, and again, the slope is 3/5 and the y-intercept is 0. We can plainly see that these equations are exactly the same, so of course their slopes and y-intercepts are the same. And when you go to graph it, that means it's the same line, and if it's the same line, we have infinitely many solutions. And that's it. If you guys have any questions, make sure that you write them down, and I'll see you at our Google Meet time around 1 o'clock.